Before we go ahead, I want to explain two things. The maintenance factor, which I'm going to write as MF, and then the utilization factor, which is UF. Now, this maintenance factor, for example, we got these lights in this room. Now, over a period of time, maybe you're going to have dust on them. So during the time you're using these lights, maybe because there's dust on them, you're going to have less light coming out of them. Yes, you can clean the light bulbs. Let's say if you're using light bulbs or the tubes, but this needs to be taken into account. Maybe the lights are going to start aging and they're going to produce a little bit of less light. Maybe, let's say the light has a reflector like this. So you got your light bulb, and this is a reflector surface, and now this is very shiny and reflects the light very well, but maybe over the years this is not going to be so shiny. And what I'm trying to say is there is a maintenance factor, and this needs to be applied. And maybe you could say that your maintenance factor is going to be 0.80, for example. So that will indicate what loss of light intensity you're going to experience decrease caused by this factor. Now, the utilization factor is also another thing that need to have take into account, and I'm going to explain it, in a similar way. So we talk about this light bulb. Now, okay, I got a light bulb here, and this light bulb, I lit it. Now, it's in the ceiling, and let's say this ceiling is white and is freshly painted. Now, the light goes in all directions and bounces in the ceiling and bounces back. Now, there is more reflection, less light is absorbed by this color, and it reflects back. So you're going to have more light. And that's what utilization factor talks about. Now, let's say over a period of time, this ceiling starts becoming more like magnolia color, and you got dust depositing there. Then this ceiling becomes darker, so absorbs more light and reflects less light, and that will be, for example, what is utilization factor. Now, it could be that you decide to put here a screen like that, and this is like a mirror, and all the light is focused downstairs, not downstairs, below. Now, this ceiling will be darker now because the light is directed in this direction, down, but that will be a different utilization factor because you're utilizing this light bulb in a different way. Now, it could be that the walls of the room are painted white, or maybe they're painted deep purple. Now, the amount of light reflected by the walls is going to change as well. So you can do your lighting calculations for a lighting appliance, but there are other factors that might affect this, and this is what we call the utilization factor. Now, it's used more or less in percentages, and what we are looking is a reflectance. And that is in percentage. So, for example, maybe a white wall might have a reflectance of 75%. Yeah, and maybe if you have a very dark wall, like it's very fashionable now, gray colors in the walls, or concrete color in the walls. Now you might have that this decreases to something as much as 30%. And that is the concept of utilization factor and maintenance factor. So basically, summarize. Maintenance factor. Is the light bulb clean? Yes. No. Utilization factor. Do we have a light bulb just hanging on the wall, or we do this and make this all mirror reflecting and we redirect the light where we want to use it? That is going to change how things are. Yeah? So you're not going to have the same light. If you have this lamp here with this beautiful new clean light bulb, that you don't have this, it's all dirty and it's not new. And that is what we're trying to do. So we are going to put these factors as an estimation into the exercise. And now, in the third video, we're going to be doing the numerical answer to this question.